Good morning, everybody, and welcome. We are two lessons away, three more lessons from finishing our work through chapter 6 or chapter 2. Oh man, this is not starting out well. We got three more lessons in chapter 2 where we're learning about solving. Today and tomorrow we're going to be looking at ratios and proportions. Yesterday we had a fairly long lesson. This one will be comparatively shorter, as there's not quite as much that we need to do here. But what we are doing is we're going to write ratios and proportions. And so by the end of the day, you should be able to create a ratio. You should know what it is and be able to create it. Also the proportions, and be able to solve for a variable inside of a proportion. Okay? So you need to write some words into your key vocabulary here. Again, you need to pause the video to write these in. I would wait till the end after I've done all the talking, so you can make sure you get all the little extra bits that I'm going to add. But you need to add these to your key vocabulary sheet. So the first thing here is a ratio. The definition of what a ratio is it uses division to compare two quantities. Sometimes we say A to B. Sometimes we'll write it like this, A to B. Oftentimes, though, the way that we're going to be using it is as a division problem, A to B, right? And that's how we say it, right? A ratio is A to B. And so what that ratio does is you might be comparing some kind of rate. I can mow the lawn this fast, and my friend can mow the lawn this fast, right? I can do it in 2 hours. He can do it in 3 hours. So that would be 2 to 3, because I'd be comparing my amount to his amount, right? A lot of the times that we see ratios are in blueprints, right? Where it'll be something like my blueprint means that 1 inch is 10 feet. Okay. Whenever you're drawing up plans for a house, you do a scale drawing on paper, and then you go out and you do the actual building. For those of you guys who are in Mr. Young's CAD class, his engineering design classes, you guys are using the idea of ratios all the time because you're creating a scale drawing in AutoCAD that is then going to be used to 3D print something or to build something later, right? So this idea of ratios should be totally familiar if you're in one of those Mr. Young's engineering design classes. And if you're not in Mr. Young's engineering design class, you should absolutely think about taking Mr. Young's engineering design class next year because they are excellent. And Mr. Young's a really cool guy. So that's what a ratio is, right? It's comparing two amounts. A proportion is an equation that states that two ratios are equal. So say we have one ratio that says 1 inch is 10 feet. Making a proportion would be me saying that 2 inches is equal to 20 feet. That's a proportion, right? Notice that all I did here was I multiplied by 2 to make that equal proportion. So that's what a proportion is when we make a statement that two ratios are equal to each other. And in this case, these two ratios are equal to each other because I multiplied the top by 2 and I multiplied the bottom by 2. Since 1 inch is 10 feet, that means 2 inches is 20 feet. Okay? So it works. It makes sense. Okay? Add these to your key vocabulary sheet, and once you're done with that, let's take a look at this example. A volleyball team plays 14 home matches and 10 away matches. Find the of home matches. I think I'm missing a word there, and it should say ratio. Find the ratio of home matches to away matches. And so if we're making a ratio, remember, it's just it's A to B, right? We're looking for A to B. So if I'm looking for home matches to away matches, the ratio I'm looking for is home matches. I see it didn't show up. To away matches. And so I simply need to write in what my home matches were. How many home matches did we have? We had 14. How many away matches did we have? 10. Ooh, but notice this is a fraction that can be reduced, right? 14 over 10 The number 2 goes into both of those things. So that's actually 7 over 5 is how we're going to want to write that. We want to reduce our fractions. What about find this one? Find the ratio of home matches to all matches. So notice that that's a little bit different here. The ratio, again, is still A to B. But this time, we're looking for home matches to all matches. So how do we do that? Well, what are my home matches? Home matches are 14. Where are all the matches? All matches are the home matches plus the away matches. So that's 14 plus 10. So this is 14 to 24. 24, I wrote a 20. See how I noticed these things at the last possible second? 24, there we go. And again, this is a fraction that can be reduced. And because it can be reduced, we should reduce it. The number 2 goes into both of those. That's 7/12 is the ratio of home matches to all matches. So that's writing ratios. Next, we want to solve a proportion. So let's take 2 ratios and set them equal to each other. And we're going to do this one without context. We're going to say 11 over 6 equals x over 30. So this is like what we did before, right? The 1 inch to 10 feet is the 2 inches to 20 feet. Except what we need to do is find the value for x that makes the proportion work, right? Find the value that makes the proportion work. And the easiest way to do that is to do this thing called the cross product. You might have heard of it as cross multiplication. It's the only time that you actually cross multiply, and it's when there's an equal sign in the middle. We call it the cross product. So you're going to multiply those two things together, and that's 6x. And then you're going to multiply these things together, and that's 30 times 11. 3 times 11 is 33, which means 30 times 11 is 330. And then we simply solve the equation that's left. So we need to divide both sides by 6. And that cancels out, leaving x equals, and then let's see, 330 divided by 6. Let's see. What do I know? I know that it goes into 300, right? So 6 has to go into 300, which means it has to go into 330. Let's just do some long division here. I think that's going to be the easiest way. 6 goes into 3 0 times, but 6 goes into 33 5 times. 5 times 6 is 30. 33 minus 30 is 3. Bring down to 0. 6 goes into 35 times. That's 30. And look at that. 55. There's my final answer. Let's do a proportion in context this time. So a recipe for tomato salsa calls for 30 tomatoes to make 12 pints. How many tomatoes are needed to make up 4 pints of salsa? So let's write what we need for the smaller recipe first. The smaller recipe, no. Let's do the larger one first, because this is the large one, 12 pints of salsa. So 30 tomatoes makes 12 pints of salsa. They want to make 4 pints of salsa, so how many tomatoes do we need? That means my tomatoes there is x. So we'll solve this proportion. X over 30 equals 4 over 12. Cross multiplying gives me 12x equals 4 times 30, which is 120. And then we divide both sides by 12. We get x equals 10. So we need 10. Now I want to point out to you that it doesn't actually matter how we set this proportion up. We can change as long as we're consistent here, right? Notice that this one has the recipes on the left and the tomatoes and pints on top. But this one over here has tomatoes and pints on the left and the recipes on the top. Let's just fill in that same information here. The larger recipe calls for 30 tomatoes, and that makes 12 pints. And this one is 4, and how many tomatoes do I need for the smaller recipe? I can use that same proportion here that I just created. And again, notice that this is a totally different equation than this one over here. This is x over 4 equals 30 over 12. This one is x over 30 equals 4 over 12. But when you cross multiply, you get 12x equals 120. And you'll notice that that is the same thing that we got right there, which means that our x value is 10. The number of tomatoes needed is 10. So you can actually set up these proportions either way, and it still works, right? You just have to be consistent. Finally, let's do one last word problem here, setting up the proportion. The elevator that takes passengers from the lobby of the John Hancock Center in Chicago to the observation level travels 150 feet in 5 seconds. So 150 feet in 5 seconds. I'm gonna draw a picture, right? Here's my building in Chicago, right? Hey. And here's one. That it's 150 feet in 5 seconds. Okay? And then the observation level's on the 94th floor, 1,029 feet above the ground. So we're way up here, 1,029 feet above the ground. Notice this is not drawn to scale. We're wondering how many seconds does it take to get there, right? Find the time it takes to travel from the lobby to the observation level. So we can set this up the same way that we set up the tomatoes one, right? I can say that x over 1029 is equal to, so this was the time I'm looking for with the feet, the time that I know with the feet that I know, and we can then solve that equation. So let's do it. Let's cross multiply here. So this is 150x equals 5 times 129, or 1029. 5 times 1029. What is 5 times 1029? Okay, 5 times 1000 is 5,000. Right? 5 times 20 is 100, and 5 times 9 is 45, which means that this is 5,145. Boom! 5,145. Yeah. Oh, goodness. Now I have to divide by 150. And, that one's going to be kind of tough to do mentally. Let's, how do we want to do this? Let's do some long division here. 5,145. Okay, how many times is 150 going to 5? 0. Into 51, 0. Into 514. Okay, 150, 300, 450. That looks like 3 times. So 3 times 150 is 450. And then 514 minus 450 looks like 64. Bring down 5. How many times does 150 go into 645? Okay, 150, 300, 450, 600. So that looks like 4 times. And that's 600, which means when I subtract, I get 45. Now I have a remainder, so there's a decimal point here. Let's bring down a 0. How many times does 150 go into 450? 150, 300, 450 looks like 3 times. And that looks like that's going to finish it off right there. So 34.3 seconds is what we're looking at. X equals 34.3 seconds. Yep. There we go. And that's it for today.